So this is a talk about modules, specifically about bringing modules, bringing your application into the modules ecosystem. And even if you already have, then staying up to date on some of the new changes that have come into modules as of Go version 1.13. So these slides and all the code that you'll see in demos are at that bit.ly link at the bottom. So bit.ly/GoDaysModules2020. And we're going to go through 3, maybe 4 demos, depending on how much time we have, to show off some of these features and some of the things that you have to keep in mind as you're migrating your code to the new modules functionality that we're going to talk about today. So a little bit of historical context. How did we get from the very beginning of Go and the dependency story of Go all the way to now where we are with modules? So obviously, I think a lot of us know that Go came out as version 1.0 without any support for dependency management. The assumption was that all the code you needed would be there in your repository. And when you built, it would just build a static binary using the code that was in the same directory. So that's why I say nil. And that was also on purpose. It wasn't just that it was left out because there wasn't time or anything like that. It was left out because the designers really didn't know exactly what was needed of the community. So it was left out and sort of left as an exercise of the community to figure out what exactly should dependency management look like in Go. So the community started to get to work. It was sort of discovered that there would should at least be a tool built into the tool chain, preferably, in this case called GoGet, that would pull code down from somewhere on the internet, from a remote. And just as then as today, we see that the locations of those packages are URLs. Most of the time, you'll see github.com/something in the URL. And there can be other URLs as well, like GitLab and other version control systems. But every single module name is named by essentially a URL identifier. So GoGet would download code into a global destination on your machine. And we still see some of that behavior today, even with modules, and we'll show that. But it was brought up that, well, sometimes an app A would need package version X, and app B would need the same package, but version Y. So we introduced a vendoring folder in Go 1.5. And this was the first time that you could configure dependency management via a config variable called Go15 vendor experiment. So if you set that to on, it would tell the Go tool to build using code that is in your local vendor directory instead of on the global Go path. So that would mean that app A could use package version X and app B could use package version Y, and they could coexist on the same system. And then after the vendor directory was introduced, then we've got a ton of tools that came out, like Glide and Dep and GoDeps, and the list goes on. And all of those tools were dedicated towards managing the vendor directory, essentially. So they each had some kind of configuration file that would indicate what dependencies are required and what version of those dependencies is required. And then it would manage updating the dependencies and installing the dependencies and even removing the dependencies, all inside of this project local vendor directory. So at that point, now we had tooling, fairly standard and established tooling. There were generally 3 or 4 sort of widely used tools that you could choose from to manage your vendor directory. And from that point, we sort of had enough consensus on generally what should the user experience for a dependency tool in Go look like. So from that came modules. So essentially, we went from nothing to GoGet to vendoring and then back to GoGet. But it's sort of deceivingly similar because GoGet, everything under the covers from GoGet is all brand new. And I don't just mean like the way that the commands are run, or a little bit of the code for fetching from the upstream github.com URLs is different. It's fundamentally brand new. So everything that happens when you do go get github.com/blah, blah, blah, all that code is literally new. It downloads code from different places. It secures the code and authenticates the code differently. And all of this newness happened in Go 1.11. So the fundamental change was from 1.10.9 or whatever it was into 1.11. Now, since 1.13, we've got a few new changes that are more notable when dealing with larger repositories, and also very, very important to understand when dealing with private code dependencies. So we're going to focus in on sort of what that code looks like. What is it? What are these changes that impact private code? And what exactly is going on under the covers from go get? And that also means what happens under the covers for go run and go build and go install and any other command in the Go tool chain that deals with installing or updating dependencies. So a lot of this talk, a lot of the content demos here that you'll see today are influenced by a lot of the questions that we get in the Athens community. And Athens is a project we'll see in some of the demos today as well. And this is also from some experience that I've taken writing Go at work, and also on some other smaller scale open source projects as well. So I'm Aaron. That's my Twitter handle as well. And I am pretty active in the Athens community, so you'll be able to find me in sort of all of the community locations for Athens as well. So the primary thing to keep in mind, and this is something that comes up a lot, is that when folks come into sort of getting ready to overhaul their dependency management to be ready for modules, to be ready for Go 1.11 and now for Go 1.13, the first question is sort of, well, what's the dependency tool? Well, there really is none. We are back to go get, like I said. So you don't have to pick up another tool, like a glide or dep or any of the other tools that we are used to using with vendoring. So now that everything uses Go, that means that all the dependency stuff is transparent. It's behind go get, and it's behind go build and go install, and so on. And that sort of goes back to the fact that all the dependency code now is hidden from you behind go get, behind go install, and so on. So what this also means, though, is that once you start running go get and getting used to the fact that you don't really have to explicitly use another tool to deal with dependencies, you kind of get familiar with the fact that go get does the stuff for you. But it's very difficult to realize and to remember that what's happening behind the scenes is different. It's deceivingly different. That's why I say deceivingly, because it's so easy to get used to it working, but it's hard to remember what it's doing and why it might be breaking. So behind the scenes, the biggest two things to remember here are where the code's coming from and how it's getting authenticated. So the code is no longer coming from hosted version control systems by default in 1.13. The code is being downloaded for every public dependency that you're using from this URL, proxy.golang.org. So that is an HTTP server, an HTTPS server, that implements seven REST APIs, 4 of which are very important. And those REST APIs essentially serve up metadata about a specific module at a specific version, and then a zip file that has the module's source code in it. So it's a pretty optimized URL. It makes it very fast and efficient to download Go modules over the internet concurrently. And in most cases, for medium to large size dependencies, this is much faster to download your dependencies than it would be to do a git clone for that repository online. So that's really good, but that can also be really bad, right? So proxy.golang.org is hosted. It's hosted by the Go team. It's Google infrastructure, so it's very fast and reliable. And it's behind a CDN, so the code is pretty close to you when you go and download it. But you don't have control over it. That's probably obvious, and that's the trade-off with all hosted services. But also, it doesn't have access to all the Go code in the world. And specifically, it doesn't have access to your private code. You also probably don't want to tell it that your private code exists. You don't want to tell it that you have a module with my secret name in it, or you have a module with the upcoming code name for your secret project in it. So it's actually very easy to accidentally tell proxy.golang.org about your private module names. And we'll get into how to prevent that shortly. Now, the second service that go get, go build, go install, and so on talks to is called the checksum database. So this is another hosted service by the Go team, Google infrastructure, behind the CDN, and so on. But this one is for hosting a global checksum database. So we're probably familiar with Glide and dep and so on. They all managed a lock file. And in that lock file were checksums that would checksum the entire module, the entire package in that nomenclature. So you could tell that if you went from computer A to computer B and you did a dep ensure or the other equivalent of downloading those modules on that system, it could checksum the new code and make sure that nothing changed since last time. Well, Go modules does the same thing. It has checksums. It actually contains a checksum for the go.mod file for the dependency in question and all the code for that dependency in question. So it's optimized to figure out, first of all, did a dependencies change? Because it can checksum just the go.mod file of your dependency. And then also, obviously, you can figure out, did the actual code for the dependency change? So once you have those checksums in your go.mod lock file, and we'll see an example of that in a second, then you are secure. No one can mess up your build anymore. No one can sneak in code behind the scenes that maybe records credit card numbers and sends them back to the attacker's server or anything like that. So that is good, and that is sort of baseline for many programming language dependency management systems out there. But the Go team took it one step further, and they introduced this thing called trust on first use. So you have your lock file that has all the checksums for your modules and their versions that you depend on. But the sum.golang.org hosted service has the checksums for every module and every version. So that's every module and every version on the public internet that's been sort of seen by sum.golang.org. And this thing is updated very frequently, so it's almost certain that within a reasonable amount of time, the module and version that you're asking for will be in the checksum database. So I call it a global chain of trust because basically it is an auditable database that tracks the provenance of a module from the first time it was seen on the internet all the way to the very first time you do a go get to bring that module source code into your application. So now that we've got these two hosted services, we have code that is outside of our control. So we've got a system now that for the first time ever in the Go dependencies ecosystem, we are not 100% federated. In other words, we don't pull code directly from the author. So in the pre-modules days, I could upload my module, my package library to github.com. And if anyone wanted to use it, you did a go get, you would pull it directly from my GitHub repository. But now there are two middlemen. There's a proxy.golang.org and a sum.golang.org. And by default, everyone will be using those to pull my code down. So there's that middleman that both I, the library author, and you, the app developer, have to keep in mind. So that's why I call this sort of layers to preparedness. If you're thinking about bringing your code base into modules or upgrading from Go 1.13, previous to Go 1.13 to Go 1.13, these are the things you need to keep in mind. So, of course, tracking and securing dependencies. If you're not familiar with the go.mod and the go.sum files, we're going to see those. Obviously, keeping in mind where the code comes from, we talked about proxy.golang.org, and we talked specifically about making sure that you don't accidentally tell proxy.golang.org the names of your private dependencies. We're going to talk about where it's stored on your machine. That's actually very important as well, because we're maintaining a cache on the local disk, and we'll see that. And the cache mirrors the subset of proxy.golang.org that your app needs. But it also mirrors the subset of the private dependencies that you need. And we're going to see how those get merged together. And then I talked quite a bit about handling private code. I'll talk quite a bit more about that because that's a very important topic for pretty much every code base that makes money. And therefore, it's a very important topic here in the new dependencies ecosystem. So we're going to start off with a demo of doing just a basic build with all public dependencies. And it's going to be using the defaults out of the box for Go 1.13. That is, it's going to be using proxy.golang.org to pull all of its dependencies from. And it's going to be using sum.golang.org to check all the checksums of those dependencies. So all right, how's the font for everybody? Can anyone not see in the back? Cool, all right. So this is a fairly simple demonstration, but we're going to show off first a little bit of what these go.mod and go.sum files look like if you're not familiar with them. So this is a pretty small application. It's a web server that's built on the Gin framework. And the Gin framework is basically just a little wrapper around the standard library HTTP server. My library is going to be using some templating to display HTML pages. So I've got Gin version 1.4 here. And I am using the Go Buffalo plush templating library, version 3.8.3. That incompatible there indicates that there are some versions in plush that are not semantic versions. And that's very important for modules. So modules is designed at its core assuming that semantic versions are used in all of your versions. Now, obviously, that is not practical for many of us to use semantic versions. And there are, I can probably personally from experience say 10 reasons why I might not want to use semantic versions. I bet in this room there are over 10,000 reasons why we might not want to use semantic versions. So although Go modules is built around the assumption that semantic versions will be used, this plus incompatible nomenclature here is automatically detected by Go. And when you do a go get, if you do a go get against a version that's not semantic, it will automatically add the plus incompatible flag there to indicate that you know what you're doing, you know this is not a semantic version, and you still want to use that non-semantic version in your go.mod file. Then the other piece of note here is the indirect comment. So that would be on the helpers dependency. So indirect is probably what it sounds like. It is not a module that is directly imported by your code. It's a transitive dependency, or in other words, it's a module that is imported by one of your imports. So the second important file here is the go.sum, or the checksum file that I had mentioned before. So you see here we've got a ton of modules. So this is the entire module dependency graph of my application. So my go.mod had 3. I imported 3 modules, and those imported everything here. So not only is this good to sort of view all the checksums, it's also a good thing to be able to view sort of all of the code that's going into your app. So we've got some checksums here for in this example, the structs library. That's the checksum here on line 3 for all the code. On line 4 is the checksum that I mentioned that's just for the go.mod. So line 3 is what we use to make sure that we got the code that we expected to get. But line 4 is used to figure out if the code that we expected to get is still using all the same dependencies that we expected to use. So this is the way to make sure that not only is dependency A correct, it's also used to make sure that dependency A is using all of its correct dependencies. So this is a way that we can traverse the entire dependency graph all the way down to the module that uses no other dependencies and make sure that every single one of those is exactly the code that we expect. And that's a very important property to secure your application. So we are going to look now at the local cache that I talked about. So there is a local disk cache, and I mentioned that it's a mirror of the subset of modules that we need from proxy.golang.org. So that cache is always located here. So it's under your Go path, not Go proxy. It's under your Go path under /pkg/mod. So I have deleted it because I want to force purge of the cache to force us to download code from proxy.golang.org to show this demo. But we will actually do this ls command again right after I build in a second, and we'll see the layout of all of the code that's been downloaded and cached. So the other piece here is the Go proxy environment variable. So this one is very important. So this, by default, points to proxy.golang.org. But you can set this on your machine to point to any module proxy. That is, any proxy that has those 7 REST API endpoints. Doesn't have to be even on the public internet. Certainly doesn't need to be proxy.golang.org. And in fact, there are other publicly hosted options available to use if you choose to, that you can point your Go proxy to. So I mentioned go get a lot, and go get sort of does all this new stuff behind the scenes. Go run is new as well as of 1.11, I believe. And go run will build and fetch the dependencies for and then run my entire application. So doing that, we're going to see, the Wi-Fi is pretty fast too. So we're going to see downloading all of the dependencies that we saw in that go.sum file that we showed. So if we just take the first line, for example, this is us downloading the gin dependency, inspecting its go.mod file, preparing to download the dependencies in that go.mod file, and then checking the hash of the gin code and the gin go.mod file. So after this line is done, we are ready now to start downloading the transitive dependencies of the gin module. Similarly, the case goes for plush, and there's the other ones that go down the line of the dependency graph. Now, the module source code is downloaded as zip files. That helps to speed things up a little bit, of course. So this is us extracting the code from the zip file. So we've got our stuff running on port 8080. I'll just show a quick little example to prove that it's working. And I just made an app that shows cat and dog pictures. This is open source, so you can see all of the cat and dog pictures that are offered. But essentially, this is the proof that we can build an app without having a vendor directory and without having any code on disk, which is nice. So the last thing is that ls command. So now I have code in my cache. So it looks vaguely similar from what used to be under the gopath/src directory. This is a hierarchical directory of the URLs for the modules that you require. So going back, we essentially now have sort of a shared vendor folder in the cloud. The vendor folder comes with some more guarantees around security, but essentially that's what proxy.golang.org is. And that's a really nice property if you're going to be sharing a vendor folder across, let's say, 100 developers. Now it's managed in one place outside of source control and secured with better properties than you could use inside of source control. So we're going to see two more demos. The first one is using dependencies that are private. The second one is going to be going one step further from that. So we're going to use proxy.golang.org still for our public dependencies, but we're going to introduce one private dependency that we're going to tell the Go tool to not use proxy.golang.org for, and instead to go fetch directly from source code. So checking out this new project. This new project is essentially the same exact app. But this time, I've pulled out some common code into this GoDays 2020 private repository. So the only difference that I'm going to do here is, I have to look up the URL. I am going to set an environment variable called goPrivate. And I'm going to set that to the module name that I don't want Go to use to send up to proxy.golang.org or to send to sum.golang.org. So by doing this, I'm telling the Go tool, I want you to download this from GitHub directly and not go to send any of this code, to send this module name to any of your hosted services. So now when I do a Go run, let me I'm going to delete the cache again. Now when I do my Go run, we can see here, this is downloading the private repository code from GitHub. If I had not set this Go private variable here, what we would have seen is an HTTP error code, 410 gone. And what that would have meant is Go indeed did send the GoDays 2020 private repository name up to proxy.golang.org. And proxy.golang.org had logged that private module name. And of course, my build broke. So it's really important to make sure that your goPrivate variable is set for your private code. And this is a comma-separated list. So of course, as your private code grows, you can either use the glob pattern or you can use comma separation in that variable. So the same app is running, and I'm going to get to the third demo, and then we'll show that app running. And they're all the same app, sort of all in one. So the question then is, of course, I used the goPrivate variable, and that was helpful, but it's very easy to forget to set that. And it's also very easy to then, by default, accidentally send private module names up to a publicly hosted repository that potentially is not even hosted by you. So the solution to that, and this is a solution that I usually recommend for development teams of like 5 or larger, is to use their own module proxy. So this is what I call a private server or my own shared vendor folder, but you'll see the nomenclature used called module proxy quite a bit. So since I am a member of the Athens development team, I'm going to use Athens. But it is very common to be able to use these, and there's a couple of other projects out there that do the same thing as Athens. So if we head over to, I've got these, this command here. This is how you run Athens. I'm using Docker to run it. There are a couple other different ways to do it. Really, the most important thing here is I am passing Athens the go_no_sumdb parameter. And then that go_no_sumdb parameter is set once. And everybody in my organization can use this Athens and doesn't have to remember to set their own go_no_sumdb. So I'm going to run this. And while that is running, clear my cache. And so now I'm going to do the same thing. I haven't set my go no sumdb here, but I have set my go proxy environment variable. Now that's very important. So now that I've set go proxy, this is telling the Go tool to send all HTTP requests, including the ones to proxy.golang.org and the ones to sum.golang.org, all to my locally running Athens module proxy. So now when I do my go.run, there we go. Ah, thank you. There we go. So now, when I do my go.run, there it is. We should be seeing lots of log lines in Athens. And now this is Athens being the middleman. And Athens now is the code that I'm running that goes and downloads code from the upstream version control system and stores it in its own storage, and then serves those modules up via its own storage to the Go tool. So this is how we unify the code that's public and my code that's private into one shared vendor directory. So this thing is working away over conference Wi-Fi, and this may take a while. And that is actually the point. So this will take a while once. But after that's done, I have my shared vendor directory in one place on high-speed storage behind a CDN, and everybody in my organization can use it. And more importantly, nobody in my organization has to do any special setup for the go no sumdb environment variable, and so on and so forth. So the fact that this is short, this is taking long, is actually a great opportunity for me to show one of the final features that's important for Athens. Well, it's just done. The one thing you'll see then if you do go to this code, and I'll share the link for that at the end, is there is this folder called Athens Archive. So what I've checked in here is the full database of all of the dependencies, public and private, that this application needs. And if you run this Docker command here, this Docker command is the same thing that I ran, except it's configuring Athens to mount existing storage. So this is basically seeding the storage of Athens for every single dependency that my application needs. And in doing so, I can essentially turn off the internet and still allow myself to build the application. So just a couple things to remember before we close. This is a fundamental change under the hood. And there are a couple dials that we've turned. We have this go proxy environment variable. We have this go no sumdb environment variable. And there are a couple others that I'll add some links to reading for. The increased security is great. We've got this checksum database. We've got this global ledger of checksums. But there is some higher complexity there, especially the complexity that you have to remember for setting up your environment variables. Obviously, you have to keep track of your private code, remember what's happening, and more specifically, remember to make sure that you don't send your private code names up to the cloud. And then I mentioned the environment variables here. We've got the go no sumdb and go private, and we've also got a go no proxy environment variable as well. And there is some reading for that if you run the go help module-private command. And then there is also on the Golang GitHub wiki, there's a lot of the same information just written out in a little bit longhand there. So again, slides and demo code is at that bit.ly link. I really encourage you to go check that out because that the fourth demo there, which I didn't get to here, is actually pretty interesting to see, especially if you can turn off your internet and run that and just sort of prove to yourself that you can still get all these security guarantees even when you're not connected to the public internet. We also maintain a lot of the more general modules documentation at docs.gomods.io. And that's my Twitter as well. If you ever need to DM me, my DMs are open. So yeah, that is about it. Thank you all for coming. Do we want to do questions? Or? So yeah, if you have questions at all, I think we can ask now. We've got about 5 minutes, and then I will be around pretty much all the rest of today as well. So you can, of course, feel free to just come chat with me.
All right, so with modules now, we don't have to work in our Go path.
That's right.
Is that an anti-pattern? What's your opinion on it? Is it better to stay in the Go path if we can, pull out of it if we have to? Is it?
I've never liked the Go path, so I would say don't work in it. That's me. When we did have to be in the Go path, I followed the rule and everything. But the minute we could leave it, I just started putting my code next to all the other repositories, Go and non-Go. So I wouldn't say anti-pattern. It really depends on your setup and your preferences. I was lucky enough personally to have the preference and the ability to be able to get off the Go path.
Hey, thanks for the great talk. I think with other languages, dependency management, we've seen a lot of vulnerabilities. I'm thinking of NPM and JavaScript. And I can see the checksum might be a step in that direction, but can you talk a little bit about how the Go team, to your knowledge, have kind of thought about this?
Yeah, I don't have a lot of knowledge on how they've thought of the CVE side of vulnerabilities. They have thought a lot along the lines of provenance and authentication. So that is, once you get code, even if it's vulnerable code, it won't change unless you upgrade to the new version. But there are some third parties that are doing some good work in vulnerabilities. The one that comes to the top of my head is Sonatype. They have I can't remember the name of their service, but they have a publicly accessible Go proxy implementation as well. And they also have a tool called Nancy. And Nancy is a Go implementation of their global CVE repository. So you can throw a go.mod file at their tool, and it will search through their database and figure out if anything that you're using or anything that any of those are using. So your entire dependency graph, it'll figure out if there might be any vulnerabilities in any of those. And then it will suggest a new go.mod file that still gives you all the code that you need, but has also fixed those dependencies. So things to Google: Sonatype Go module repository, and then the other one is Sonatype Nancy, like the name Nancy. And the Nancy is open source as well, so it's very helpful. Other questions? All right, well, I will be around for the rest of today, so just please, I don't bite. I love to talk about this stuff, especially in a quieter setting. So please feel free to come up to me, and I would be glad to talk to you. Thank you, everybody.